Hello everyone, very warm welcome to one and all present here. My name is Akash Arya and I am MTech MEMS department student here at IIT Bombay. And today I am going to discuss about the case study presentation of the subject numerical methods MM641. So in the case study we'll have to present one research articles to here. So the research article title is Modified Jiles Atherton Model and Parameters Identification. So they are finding the parameters using false position methods. So the physics of the Modified Jiles Atherton model is, so basically it describes the hysteresis phenomena where we find the hysteresis loop. And so basically that is related to physics. And so first we will discuss about the Jiles Atherton model and Modified Jiles Atherton model. What is the basic difference between these two? So in the Jiles Atherton model, that is widely used for the hysteresis phenomena, and the basic the difference in concept is the in the Jiles Atherton model we use irreversible magnetizations, but in the modified Jiles Atherton model we use total magnetizations. So then we use the nonlinear equation that is grouped, and then we find the parameters using these nonlinear equation, and we can also find the total differential susceptibilities. And approach to find the method is false position method, right? So again, so these are the governing equations. So basic fundamental equation is we can take total magnetization equal to m reversible plus m irreversible, right? And we can see the Giles Atherton model and modified Giles Atherton models equations. So here in Giles Atherton model we are taking the m irreversible, that is h equal to h plus alpha m irreversible, and here in modified Giles Atherton model we are taking the total magnetization like h equal to h plus alpha m. And now we find the another differential susceptibilities equation chi equal to dm upon ds for both the models modified and Giles Atherton. So if we see the basic difference in these two, like if we do the c equal to 0 in modified Giles Atherton models differential susceptibilities equations in these two dm irreversible upon dh and dm upon dh, if we take the c equal to 0, so the modified Giles Atherton model will be like Giles Atherton model. So expression will be like, so this is the basic difference, like in c equal to 0 a more modified Giles Atherton model will be converted to Giles Atherton model. Now the next governing equation to find the parameters. So here we describe the how we can find the parameters using the nonlinear equations. So we have found here the three nonlinear equation, and one is the parameter, that is initial parameter. So here the alpha, c, k and a, these are the four parameters that we'll have to find using false position method. So the if we you are familiar with the BH curve or MH curve of the hysteresis loop. So we are taking h equal to 0, m equal to 0, so at the initial points, so we are finding the neta initial values and the parameter c equal to 3a chi in initial divided by 1 plus alpha chi initial into ms. Okay, so these are the first at the initial point we are finding the one parameter, and for the other three parameters we are taking different values of h and m. So at the remanence point we can take h equal to 0, m equal to mr. So we are finding the first nonlinear equations in terms of alpha parameters, and the second at the cohesive point we can take the h equal to sc and m equal to 0, and we are finding the second nonlinear equation in terms of k. And the third at the coordination of loop tip or at the saturation point we can take h equal to hm and m equal to m maximum values. So we can get the function in terms of nonlinear function in terms of a. So we have found the three nonlinear equations and one parameters, that is initial at the initial point c. Okay, so these 4 points we'll have to find, right? So the identification techniques from which we'll have to find these parameters values. So finding the parameter c, we can take chi initial is given from the experimental values, and ms is also given, that is for different values for the different materials, and alpha and a is our initial values. So basically we put all these equation, and if we satisfy this relative error criteria less than some values of epsilon, so that will be the mm, no, final value of C. And for finding the nonlinear equation, so we have taken for an example one first nonlinear equation. So here we have taken the alpha as an alpha 1 and alpha 2, A and B. So basically if we know about the false position method, we'll have to take two initial guesses, and these two should be of opposite signs. So basically we can get F A and F B into less than should be less than 0, right? So these criteria should be followed, so then we can move forward. And if we take in k steps, the solution is beta k. So we can take we know the formula of these two slopes. From these two slopes we get, so beta k we will have found a f b minus b f upon f b minus f a. So these are the basic formula. If it will be greater than 0, so then we can find a k plus beta k, and these iteration will be go move forward, and as beta k then we can found the another. Okay, so and now the final condition is if a function of beta k of mod will be less than epsilon, so that will be the root final value of the one parameter alpha. And similarly we can find out for the k and a. Okay, so for other two nonlinear equations, right? So these are the two basic techniques to find the parameters. So we have found the four parameters from these techniques. Okay, now if we come to the results and conclusions, so in the table 1 you can see the experimented value of that parameters, all the parameters. And in the JA model or table 2 we can see the identified parameters using our techniques, right? And if we see the graphs, so we can see the great agreement between these two experiment and parameter founded from false position method. And if we zoom up this half graph, and we can see that the best fit curve of modified Jiles Atherton model will be of false position methods, right? So this is the basic conclusion we have found. Now the why we are using the false position method over which other methods are available, because if we compare with the bisection method with the so we have seen that in the bisection, if the initial guess is near to the root, even if we'll have to take more iteration a plus b by 2, then we'll get the final root. So this can be the slow convergence. So basically we are taking the FPM. And if we compare with the second method, so in the second method we all know the convergence is not assured. That's why we are taking, like, putting the limits on the maximum iteration, so it should be less than this, then that's why we are finding. So this is the advantage of FEM over the second method. And if we go to the Newton-Raphson, if we okay, comparison with the Newton-Raphson method, so in the Newton-Raphson method you all are familiar, so we'll have to take derivatives. And it also has a cons, like it doesn't always convergence. So basically, so if we take all these three regions, compares with these three methods, so we can take like false position method, right? Now if we come to the next slide, so okay, so these are the resources we have got, the all the details and everything, research articles you will find. And these are the references, and these are the two peoples who have given this model or this concepts. And I'm thankful to both the professors. Okay, right? And thank you everyone, this is the end of the slides. If you want anything related to this concepts and presentation, you can go through the links given below. Thank you so much, thank you so much guys.